Ladies, gentlemen, and machines, welcome. We are here at IIT 2020. The theme of today's panel is the art of data science, a nuanced discussion about AI and how to use data for business, for the good of mankind, and various applications within those spheres. We have a very distinguished panel here. Santiago, who works with AI and edge infrastructure, more on the hardware and software side supporting AI. We have Lewis, who is going to be talking about swarm models and really teaming machines with humans. We have Kirel, who is a data artist and an expert in data visualization. Kirel is logging in from France, and Sonam, who works with the financial markets, logging in from Mumbai. A couple of the things that I think folks in the audience would appreciate, I think many of us, this dates me. You can see some of the gray hair. I think Don Knuth had the art of computer programming, right? A lot of us in the audience probably grew up with that. So that might give you some indication of what sort of things we will be talking about. Much like programming, there are many ways to find solutions. Data science tends to be a little bit more nuanced. There are some interesting decisions with respect to what data you want to use, how you want to set up the problem with respect to the modeling. And then in many cases, the answers need to be interpreted as well. It's not black and white. It's a very nuanced interpretation. One of my favorite examples, I think Lewis and I talked about it a couple of weeks ago, and he'll dig deeper into the US election forecast. But when I woke up the day after the elections here, it was very confusing to get a handle on what the state of the race was. Deep learning wouldn't have helped. It's really the right kind of data, along with some analyst opinions, human commentary that would have helped. But it took most of us here about 15, 20 minutes to sort of figure out what the state of the race was the next morning. So that's sort of one example of, how data gets interpreted with respect to different tasks. But without further ado, I think we'll get started with each individual initial presentations. So Sonam, take it away.
Thank you, Dr. Ganesh. So I'll introduce myself. I'm Sonam Srivastava. I'm the founder at Right Research, which is a Mumbai-based quantitative investment management firm. When I say quantitative investment management, we use a lot of data in our decision-making process, and by virtue of that, we also use a lot of artificial intelligence and machine learning in what we do. So I'm going to talk about the art of data science in finance. A data-driven financial process looks something like this. It is very similar to any other data-driven process. You have your data sources, you have your models, and you have your result. The data sources in finance are very far and wide. And like Dr. Ganesh just said, data sources are very, very much more important than the process itself. So it is a very fundamental part of this process. Data sources in finance can be fundamental, like I said, coming from the company financials. They can be technical based on price volume data. You can get data from sentiment, news, or anywhere else. And in finance, the process or the brain of the model involves maximizing returns and minimizing risk. It's all about risk and rewards. And you also are a little bit aware about the costs. And that is pretty much how a data-driven financial process looks like. Whereas artificial intelligence is used in this process, it is actually used everywhere, in every aspect of this process. And the use of artificial intelligence is actually not very new in this field. The backbone of model finance, which are the factor models, where various researchers or analysts across the world have designed these models that can now describe 95% of the variance in the financial markets using like 12 to 15 financial factors, which are based on like widespread research that has come up over 80 years, which make this field very, very robust. And I find this very fascinating and very artful in the way that how these models have come about in the 80 years. They are orthogonal to each other. They're very diverse and they add such a lot of value. So this is the data science of the old age of over the years. But in the modern sense, a large part of research goes into, again, the financial factors of the data. With the the boost coming in the natural language processing flow in the unstructured data research, there's a lot of researchers who are doing a lot of good research on sentiment analysis, on social media data mining, etc. And these models are very, very powerful, which are adding a lot of value to financial modeling, and they're proving to be very, very beneficial uh, for a financial portfolio manager. And not just that, we have some very specific models, like people are now forecasting economic data on the real time. People are modeling country risk or geopolitical data, etc. You can model like website scores to model how what a web-driven company will perform, this ESG, M&A rumors, etc. So data is a very, very rich field where a lot of AI-driven research is going on. And coming back to the core model, where I said it's all about maximizing returns and managing the risk. So in finance, so this is one of the models that I want to showcase here, where I talked about these factors, and all of these factors are weak predictors of returns. Like one factor will prove good in one time horizon, like momentum is doing well, but maybe some time back, low volatility factor was doing well, and something else was doing well at some other time. So no one factor does well at all times, and a combination of factors is the best way to go. And that's why I like the multi-factor approach, and data science or artificial intelligence, because of the use of unstructured data, their non-linearity, and their capturing of complex relationships could be very, very powerful in finance. So while a single factor can be a weak predictor, if you combine them using machine learning, they can be a very, very good predictor of returns and can be a very powerful model. Last but not the least is I want to touch upon on this topic of reinforcement learning in finance, which is a model-free financial model, where financial agent, where AI is trying to replace my job, where AI fits into the financial system. It takes an action, it gets a feedback from the financial markets, and that's how it learns from the data. And I don't have to tell the model that, okay, maximize return or minimize risk. It learns that on itself, and we published this result sometime back, where we show that such a AI-driven model can outperform many of the traditional models, and this is a very good uh, and interesting area of research. So that pretty much concludes my presentation. I would like to invite the next presenter to go on.
Yeah, thank you, Sonam. So Sonam is from Right Research. Somebody was asking, a boutique investment research firm out of Mumbai. Thank you very much for covering some very interesting aspects, I believe. Next up is Santiago from blaize. Santiago, take it away.
Thank you, Ganesh. Santiago, Vice President of Platform Engineering in blaize. All products come from me, actually, in the company. In addition, I also run operations, quality, and the program management office. Everything else you want to know about me, you can go to LinkedIn or our webpage. Today, we're going to talk about art. You are as old as I am. When you think about art, usually the first thing that comes to mind is the end result. For me, that end result will go to the left of the picture. The older school Dutch painters, Spanish painters, maybe all the way to Sorolla. More modern people will go to the right, where you get through Miro, Picasso, or all the way to Pollock. So about 20 years ago, I visited the Picasso Museum in Barcelona. I was coming from Madrid to see El Guernica, and I was looking forward to see all Picasso great paintings. What is my surprise when I walk into the museum with my wife, and we start seeing all these, at that time, terrible sketches and drawings all over the museum, and not a single great painting. So as we walk through the museum, and I see everything Picasso had done and scribbled in his notebooks for years, I finally realized that I was missing a piece on the art. Actually, I was missing the journey of art. To get the great painting at the end, he spent years preparing and years preparing the data and then manipulating the data that resulted in the work of art. Since then, to me, art has been personally more of the process where I collect the data, massage the data, and eventually display the data. In that process is where I really enjoy the art, I apply the art, and at the same time, learn the learning process to get to the final work of art. So today, in a few 4 or 5 slides, I'm going to show you something instead of something that we have done. I'm going to show you something I am doing right now. So I'm going to show you half of the work. I started 2 weeks ago, weekend project, uh, usually after dinner on Saturdays and Sundays. So for the past 2 weeks, I spend my time in trying to solve a problem. And when I try to solve a problem, my process starts really with the basic infrastructure. I start with, I'm going to code something that is going to go into some software or hardware platform. And I start thinking about what font I'm going to use. You go to the web, you're going to find dozens to hundreds of coding fonts. Why would that be there if people could be all happy with Courier? However, we are not. I spend hours every time I have to do a PowerPoint presentation picking the right fonts. There is something visually appealing, and there is something that makes you want to do more when you are looking at something that is um, nice to see. From fonts, I go into the coding, where some people code with art. If you have seen the Ouroboros coin, this is actually a real program that is able to convert itself into about 118 different programs as you execute it. But the author not only did that, Yusuke Enon, he also coded in this way. Why spend time in just coding to place it this way? Because it's, as we do our work, we like some art built on that. And we have been doing that since the early years of human race, always putting a spin on art on everything we do. Once I start my coding, I am more of a monofont type of person, everything very square, everything nicely laid out on the screen. I move into the algorithms. So for this particular problem I wanted to work since a couple of weeks ago, I decided to jump into the Mandelbrot set. Probably you have seen this in the past. It's an interesting problem which has been solved many years ago, but I wanted to give it a different spin. So I start with my set, which basically, you go to Wikipedia, you can learn that it's a set of numbers that you can, complex numbers that you can apply on this function, and they never go off a certain limits, which allows you to display them and generate images like the one you see there. Now, if you zoom in into that image, continue multiplying those numbers, you start seeing what you see on the web. The Mandelbrot set images, that's zooming in into the original image. And if you color that properly, the interesting property about this set is that you can zoom ad infinitum. You can keep zooming forever, and you will always see a visual, different forms coming in. In addition, I look at that and I wanted to see this not in 2D, as you see here. So I wanted to see it in 3D. So I actually took the data and quickly flip it into a 3D chart. So what you're seeing there is the basic one on the right, top right, but on a 3D display. So here was here is the thing I am trying to work on. What if I could navigate the Mandelbrot set on a 4K display at 30 frames per second? Yeah, imagine just zooming, panning, tilting into this figure as you go into the set, and you keep exploring those images that show up. I just show you as you keep zooming in. So that in 3D, and you want to navigate that. At 4K and 30 frames per second, that requires over 300 teraflops of operations. If you want actually to see some high detail on those slopes, you are talking about petaflops. So my company, we are working in under the desk technologies that you can start looking at those things as you explore your data and you try to make sense of it. And you are looking for ways of actually looking at that fast enough so you can actually do it in a relatively short period of time. So continue with my exploration. I got the set. I got from the web, the algorithm that resolved the set, and it looks like this, which is not visually appealing. So my first interest was to change that in something I like more. That's exactly the same thing using complex numbers. Wonderful. One line, we do the calculation. A problem. Now you start getting into well, how do I do that? Because the first one I can do with Python very easily. The second one is more difficult. Still, I started in Python and I applied the algorithm on the top. And I ran the actual loop that comes from Wikipedia. And I found that it took 6 minutes to run one frame at 4K. Starting my optimization. Remember, we are talking about art. We are learning our data and we are learning how to process it, and we are adapting something we like. So my first attempt was, well, the problem is that this is two loops. Let me make a one tensor. And my time went immediately down to 17 seconds. I am running on an Intel processor, 8 cores, 3 gigs, and that was good enough. So 2 tensors, 12 seconds, and now we hit the limits of Intel. So how am I going to get to my 4K at 30 frames per second? Enter hardware. That's where I start trying to apply the accelerators we are working on, machine learning and AI, which essentially do these operations natively to solve the problem. And this was last Sunday around 11 p.m., where I finished coding my OpenCL for this, just the 2 tensor version of this. And as I hit go, I got this. And I went to bed. That was my exploration and my data analysis. When I got to that image, I just set up my next challenge for the next weekend. First, why is this image kind of rotated on a 3-dimensional axis? Makes no sense. It should look like the one I showed you before. Second thing is there is some effects, vertical effects in the figure. So maybe my OpenCL was not good enough. Maybe I coded incorrectly. I don't know what I have done. But as you can see, as I go through the process of developing something and go from software to hardware, trying to hit my goals, I am constantly looking at the improvement and the art of how to work with this. Hopefully that will give you an idea of how I see art in data and actually in the process of creating and using the data. As a last note, as we are in Christmas, this is zooming in the Mandelbrot set randomly. I tried a couple of weeks ago when I was working on Python at that location, 0.55, 0.65J. Happy Christmas.
Thank you, Santiago. Actually, we have some snow on the ground in Pittsburgh here. But the one thing this reminds me is I think these days we can say art imitates technology and technology imitates art. From more hardware-centric type of commentary to more human-centric commentary, let's go to some of the SWAM methodology from Lewis at Unanimous AI. Lewis, take it away for us.
Hi, so I am Louis Rosenberg, CEO of Unanimous AI, and we are a very different type of AI company in that most AI companies work to replace human intelligence. We use AI to connect groups of people together to amplify human intelligence. And so with that, let me start with a very controversial statement in the world of AI, namely that people are smart. It's the foundation of what we do, which is that there's this amazing human database out there. Every person has knowledge and wisdom and insight and experience and intuition and instincts. And so the question that motivated me to go in this direction almost a decade ago was, well, how do we best harness the intelligence of human groups? And to answer this question, I started with another question, which was, well, how does nature do it? And it turns out nature has been tackling this problem for billions of years through many different species that have large groups of organisms. And nature evolved optimized methods for amplifying the intelligence of groups. And to give you a sense of what kind of group am I talking about, you think of a school of fish. There's a school of fish, they function as a single superorganism. Each fish has a slightly different view of the world, has slightly different experiences, has slightly different perspective. Well, how does nature take all of that those different pieces of information and allow that school to make the best possible decisions? Well, nature evolved a method. Well, what nature does not do, nature doesn't take votes or polls or surveys. There's no survey monkey in nature. Nature also doesn't analyze big historical data sets. There's no big data in nature. What nature does is it forms systems, real-time systems with feedback loops where the groups can converge on optimal solutions. And biologists refer to this as swarm intelligence. And swarm intelligence is the reason why birds flock and fish school and bees swarm. They are significantly smarter together. And so the question that got me very excited was, well, if birds and bees and fish can get so much smarter together forming systems, why can't people do it? And it turns out we can do it with the right technology. And so for the last 6 years, my team at Unanimous AI has been studying natural swarms and developing the algorithms and interfaces that allow human groups to form similar swarms online, moderated by AI algorithms. And so this is a natural swarm, and this is an artificial swarm. And so what you see here on the screen, each of those little yellow magnets is actually controlled by a person. They can be logged in from anywhere around the world, and they're using their magnets to pull on the swarm. And there are AI algorithms that are watching everybody's behavior to determine who has high conviction, who has low conviction. It's basically processing their behaviors and determining how the swarm should move. And in this case, it's allowing this group to make a forecast. And that's actually a financial forecast that's happening. And I'll show some examples in a second. But at the highest level, a swarm, the way we define it, is a real-time system with participants acting and reacting and interacting, revealing their strength of their convictions to the underlying AI algorithms that allow the system to converge on a solution. And so then the question is, well, does this work? And so we've worked with major universities over the last few years to do rigorous studies. And so we published a study last year with researchers at MIT where we looked at groups of financial traders. And we said, can financial traders log into our system and make financial forecasts together as a swarm. And so we gave them this study where they were going to make weekly predictions of the price of gold, the price of oil, and the S&P 500. And the published study, which is on our website, shows that by forecasting together as a swarm, we increased their accuracy by 26% on average as compared to the financial traders making individual forecasts or forecasting together by taking a vote, by just combining their input that way. And so we saw a really powerful result. We had another study that we published with Stanford Medical School late last year in the journal Nature, where we had groups of radiologists work together to diagnose chest x-rays. And these were small groups, 5 or 6 radiologists. They were at different medical schools. An x-ray would pop up on their screen, and then they'd work together as a swarm to determine, does this person have pneumonia or not? And what we found was that when they worked together as a swarm, we reduced their diagnostic errors by 33% as compared to if they had just taken a vote or worked on their own. We also compared to the world's best machine learning system, and this group of people also outperformed that solution. We published a study last year with some researchers at Oxford University looking at forecasting sports. And in this case, it was in the English Premier League forecasting football games, and we brought together swarms of just regular sports fans. And so we had a group of regular sports fans, and they came into our system and they predicted 50 consecutive games, which is 10 games a week for 5 weeks. And the individuals on their own were 55% accurate in predicting these games. If they took a vote, they got a little bit more accurate. They got up to 58% accurate. But when they worked together as a swarm intelligence moderated by AI algorithms, they were 72% accurate. So we saw this, again, this big boost in accuracy. And then we published another study last year with California Polytechnic, where we had business teams, small business teams, working together as a swarm to make decisions. And so we gave them a standard subjective judgment test where they took the test alone as individuals, they took the test by taking a vote, and they took the test as a swarm. And what we saw was that we reduced their errors by 52% compared to what the individuals could do on their own, and reduced their errors by 41% compared to taking a vote. As Ganesh mentioned, we also forecasted the 2020 election, and we were actually last week we were written up in the Wall Street Journal because our forecast was perfect for predicting all of the battleground states, all 12 battleground states in the U.S. who would win, Trump or Biden. And what was interesting is that all the major polls failed, and these major polls, collected data from hundreds of thousands of individuals and tried to forecast. We made our forecast with just 50 randomly selected voters. They came into our system, and then they forecast each of the battleground states, and we had correct results for all of the battleground states. So ultimately, the technology that we have is called Swarm AI because it's modeled on swarm intelligence. And at a high level, it looks like this. You start with a networked human group. They could be anywhere in the world. The important thing is that these people have knowledge and wisdom and insight and experience, and we connect them together in real time with these AI algorithms that watch their behaviors, and we turn them into essentially an artificial expert that can answer questions, and those questions will give us more accurate forecasts, decisions, estimations. And so that is the power of nature's swarm intelligence combined with the power of AI, and that is what we do.
Thank you, Louis. And one of the messages that I think I take away is sort of the power of diversity. I know we have a diverse panel here. A number of the attendees are very diverse. And you mentioned the Premier League, I think years ago, Mike Moritz, one of the co-founders of Sequoia, wrote an op-ed in the Wall Street Journal about how the English Soccer League improved quite a bit once the immigrants started coming into the soccer league there. He had made a quality as well as financial argument, very interesting. You can sort of Google it. But thank you. This is a very unique perspective on AI and data science. And I think one of the ways humans get to understand large amounts of data is by visualizing things. You know, we have 5 senses. Our most dominant sense is still the visual system, and that gets us to some of Kirill's work. So take it away and show us some pretty pictures, Kirill.
Thank you, Ganesh. So let me share my screen. So today, yes, I took the thing literally, right? When you asked the art of data science, so I'm going to talk about literally transforming data science into art. And this is what I do as a data artist. So basically, if I had to define data art, I do this as a professional data artist. I would say that the difference between data art and data visualization could be, I mean, maybe you're not really familiar with the field, but basically in data visualization, you try to be the most effective at communicating something from a data set, statistical values, anything. In data art, the goal here is to create emotions, first and foremost. But because it is based on data, this is not just random art. It has a more objective value. It's not only the sole, artist's imagination, because it is based on a data set. So basically, when you look at a piece, maybe you are attracted to it because you like the colors or the shape or anything. So you get closer. You want to see what it is. Then you can maybe read the description, and then you realize, okay, this piece here is not only abstract, it is based on data set. So maybe I want to learn more about this data set, try to read the description and ultimately develop the cognition that you have about a particular phenomena, about this data set, and also, on yourself. That's the whole point of art, I would say. So just to recap, the data art thing is really about first emotions, putting the message out there because it's still an artistic endeavor. And at the same time, because it is based on data, develop cognition. So I want to show you some examples to have a better idea. And one is in the Montreux Jazz Festival. Maybe you're familiar with this. It's one of the most famous music festivals. It's in Switzerland. And basically what we did was to, take old data for more than 54 years. So it's pretty big. It's 11,000 hours of video, more than 100,000 pictures, and approximately 2.7 petabyte of data. So, it's quite big as a data set. And basically we, started to create some initial data visualization to give a better idea of what the data set was, composed of. And then, slowly graduating to a more data art piece where you really want to have people involved, experience the festival. So I just want to show you some of the overview of what we did. This is a map of all the artists and their location on Earth. Basically, as you can see, it's very diverse. We have people from India here. We have people from Australia, Japan, New Zealand, most of the countries. Some of them are missing. And when you click on an artist on the point here, you would see these green arrows. And these links are actually showcasing the musical similarity between artists. So remember, this is not music that you can listen on Spotify. It's it was played at the Montreux Jazz in a very specific setting. So to extract these links, what we do is we analyze the music, we extract the rhythm, the melody, the chords, harmonics, and so forth. And we try to compare songs together and say, okay, maybe those songs are connected because they sound alike. And of course, this measure of similarity is also very subjective. This is why we do, we listen to what people like and we try to basically guess their taste in music. And the cool thing about this is once you group songs per artist, you can have a measure of similarity between artists. So this map was used by ethnomusicologists, so people studying the origin of music and how one artist can influence the rest of them, such as B.B. King, as we saw, which is very the most popular musician in the festival. So you have all this kind of interactive stuff where you can play with the music, and it's pretty cool to see all the location. But let's go towards something a bit more artistic. So to do that, instead of having the link between musical similarity, we can create another type of network, which would be the network of all the artists connected if they've been playing together on the same stage at some point in time. Because, you know, most of the artists, they come several times at the Montreux Jazz, and most of the time they change their lineup. They come up with a new drummer, a new bassist, a new guitarist, and so forth. So you can start to, you know, if you take all this data and you flatten it all, you start to have this interesting network where you connect one key artist, such as the singer or the main artist, to the rest of the band. And over time, you create a very connected and interesting network. So this is like a part of the image that we created. As in the middle here, you have BB King in yellow. You have some Santana, George Duke, you know, the very, very popular artists, anyone you can think of, Aretha Franklin, I don't know, any jazzman, bluesman, or even like Michael Jackson came once, Queen, Led Zeppelin, anyone, and like choose any very popular artist. It came at the Montreux Jazz Festival. And when you unzoom a bit, you'll see this is like the overview of the network that we created. And it seems that everything converges at the center. And because the music in itself, if you look at the musical genres at the center, you would have mostly jazz and blues. And if you think about it, it makes sense. Because when you do jazz and blues, especially in those Montreux Jazz thing, you invite other artists, you jam with people, so you create collaborations. So it makes sense that the most connected artists at the center would be jazzmen or bluesmen, right? So this is an overview. This is like it's a 2D projection of a 3D network that we created, and we put this on display in a museum. And this basically was the structure. It's like a small planetarium. It's a full dome. So you would enter the dome and use this controller that you see on the right here to basically be able to browse the different artists, the network that you saw, and click on an artist to have all the concert associated with this artist, and then all the songs, and of course listen to the awesome music of the festival. So I cannot really show you the whole experience because everything is copyrighted, but I think you have an overview here. So you are inside the dome, you take the controller, you move it up, and you have this fisheye effect, so you can, you know, move things around. And at some point you can either zoom or click on the button, and all the different concepts will, you know, come up with a cool animation like this. And basically the idea behind this is, of course, to create an artistic experience, but it's really to talk about digitizing all this content. What is a data center? How do we extract musical similarity? What are the AI algorithms that we can use to create all these kinds of network and extract the features from the song? And by presenting an artistic experience, people are less frightened by the AI in general. Because if we work in AI and all in tech, we don't have the same lens as other like general audience would have. So for most of them, it's something a bit scary. You know, we talked about this earlier. Maybe AI is going to steal my job and everything. So this is a bit, you know, difficult to reconcile, especially if you come from a scientific background to the general audience. And I thought that, you know, I experienced that now if you create data art pieces based on data and AI, people are more engaged and they are very open because art is not threatening in itself. So it's just a way, another unconventional way to basically talk about the same technical subject that we all work with, but in another way. So just to finish, I have tons of other pieces to show you. Maybe we can talk about this later in the discussion, but I also have some things about AI that I could show you, where we synthesize images and basically create some smooth animation like this. So the idea here is a bit the same. Instead of having artistic data visualization, we use AI to generate positive emotions, and this acts as a way of talking about what is AI and the art of data science in general. So I hope that you like this. If you want to connect, I have other pieces and everywhere on YouTube with fractals and stuff. So please let's connect if you want to know more about this. And back to you, Ganesh.
Thank you, Kirel. Couple of thoughts. I think you're talking about different genres. And I think AI is trying to sort of take all the Picasso paintings, and these are sort of deep learning techniques, and trying to create a new Picasso painting. Likewise with music, and I'm glad you mentioned jazz, because Pittsburgh has a very nice history with jazz. And likewise, one of the creative elements that I talk about as a grand challenge is, I know you talked about music and art, likewise in language, right? Take something like the New Yorker cartoon contest, right? When will AI sort of win something like that? And not just using some statistical large language models, but be also able to explain it. If a child or somebody from a different culture then get the cartoon caption, it should be able to explain it and should be repeatable and so on. And I think Louis brought up SurveyMonkey. I was just thinking, the thought that went through my head was, we're actually surveying monkeys, right? The Jane Goodalls of the world. So that's sort of one way to learn from different intelligent species. I think there was a question about mixed reality, and I would again argue the swarm, as well as some of the things Kirill presented, are examples in some sense of mixed reality. And that gets me to this sort of the ultimate answer these days, people say, is teaming, right? Human machine teaming. On the one hand, we've also had some high profile catastrophes. And by that, I mean the Boeing plane crashes, right? That was sort of a failure of human machine teaming. We have to learn from it, because it will have applications for autonomous driving, but it also has applications in Sonam's world of financial markets. When markets move, we've had the VIX in the US move from 20 to 80 and back now to 20 this week. Those are huge moves. So billions of dollars are being traded. Likewise, in an operating theater, when the patient is being cut up, if there are some irregular operations, so to speak, what do? You have to take action in real time. So do any of you folks want to talk about human machine teaming a bit more? Who wants to go first? Just raise your hand so I know who to call on. Louis, why don't you take it, and then we'll go to Kirill.
Sure. So in the, one of the things I talked about in my presentation is this study that we did with Stanford Medical School, where we had doctors diagnose chest x-rays. And I also mentioned that that we had groups of doctors, and they were able to outperform the world's best machine learning system when they worked together as a swarm. We then did a follow-up study where we looked at how the swarm of humans diagnosed chest x-rays and how the machine learning system diagnosed chest x-rays. And we found that they had very different strengths. The machine learning system was very, very good at diagnosing cases that fit the data set, that were familiar, common cases. They were actually better than the humans at diagnosing the common cases, whereas the swarm of humans was better at diagnosing things that were unusual. They were better at extrapolating to places that were outside of the standard data set. And so we then did a follow-up study where we said, well, what if we had a triage system where a case came in, and if it was fit the data sets, the historical data sets well, the machine learning system would diagnose it. And if it didn't, the swarm of human doctors would diagnose it. And we ended up with accuracy that was better, significantly better than either system on their own. And it basically, it demonstrated to us that ultimately there is this, human machine partnership. Once you start to really understand, what are the machines good at where you don't need people, but where are the places where humans really are important? And in the case of diagnosis, it was, the humans have this remarkable wisdom. They have, you can call it intuition, you could call it insight, but they have this ability to diagnose patients that are presenting in ways that are just really unusual. And the machine learning systems can't do that. And so with the appropriate way to combine, we can really build systems that take advantage of the strengths of both. And I suspect we'll see that in all kinds of fields, from financial forecasting to product development to basically everything.
Kirel, do you want to add to that?
Yeah, I mean, to illustrate that, I mean, it's exactly the same thing in also art, or some people say, like a few years ago we had this debate, or if you train a machine to synthesize, to create new imagery, is it really and like, do we need an artist anymore? Like, should we patent the work to the machine itself? Especially in France, we are really good at copywriting, authorship and stuff like this. People have been crazy about this. It's a machine. There's no artist anymore because the machine is going to replace humans. And I think it's exactly as you said, Luis. No, it's like a tool. It's equivalent to saying, oh, now 30 years ago we had Photoshop. So now if we create something with Photoshop, it's a machine, right? The human has no part in it. But it's to forget that if you want to make a system like a machine learning system, you need to train it, and especially you need tons of human input to make all the parameters, and especially if you synthesize like 1 billion different images, just to select the one that gives you emotion and that hopefully appeals to other viewers is also where the creativity, intuition, human part comes in. But as you said, machine is very good at exploring tons of unusual design. So this is where we can gain time, training, and go outside the box with our thinking. Because for us, for instance, if you train machines to generate new imagery, such as a combination of dogs and objects at the same time with fishes, it's really difficult for us to imagine. But for a machine, it doesn't really matter. So you can throw tons of different parameters and come up with very surreal shapes. I tried to show that a bit in the video, on the AI generated video. It's called "These Are Not Flowers" because what you see they look like flowers, but all the individual ingredients are completely not flowers. So like having this collaboration between human machine really helps develop the creativity and design. So it's a great thing, and we should not really be afraid of this.
Sure. No, thank you. Sonam, any comments from sort of a business perspective on how some of your clients are looking at data science or reinforcement learning? I know in India, maybe people are looking at it a little differently than the rest of the world, but with respect to your clients.
In India, I think people do not really trust machines to come into the financial market as much as it is there in the West, like in Europe or in the US, because the financial markets are relatively newer in India. So humans are first getting a hang of it for machines to come in. But yeah, so human, like for the work that I do, I see that I work along with the machine. My machine can do something really, really good, which can be really profitable, but I have this human element where I have to always, monitor and improve and get insights from the machine. And that, I think that partnership is really, really helpful. And also, like commenting on the intersection of human and machine, I think a lot of these machine learning models like deep learning, neural nets are based on, the human mind. And there are various models like you talk about, they simulated annealing, which is a model based on annealing of steel. The SAW model that Luis talked about is again a human model, or like a natural model that we are trying to mimic in machines. So there's a lot of overlap between what we do as humans and how we're trying to create machines to do the same thing.
No, that's helpful. And Santiago, from your perspective, sort of what are your clients prepping for? You're providing the infrastructure, be it hardware, firmware. Is it more support for deep learning, or are they thinking about new things? Do you want to sort of talk about it? And also, I'm being told that a lot of people are interested in this session. So from an audience perspective, if you folks want to put in some additional questions, we'll be glad to take them. We have about 25, 30 minutes still remaining. But Santiago, on your clients and infrastructure support, if you want to chime in there.
Actually, I live in the supply chain management hell and reality of industries today. So what our customers want, they want working money-making solutions. So I am 100% on the industry. So what type of applications we see? The application that probably the most relatable to everybody in the audience is I have a humongous warehouse and it takes forever to move things around. And all these robots I have running around, they keep making mistakes because they are on a single track, right? How can I make them more intelligent so they stop breaking? That's the type of application we see. I have, I am a major retailer and I had no idea what is my clothes turnaround. I don't have any intelligence in the store. Can I deploy a small camera that is sending analytics to me and telling me daily how many people are trying this dress? How many times all these things are happening in the store? Or even more practical, I have a fleet of 10,000 trucks. How many of my drivers are taking lunch breaks for more than 2 hours? So I stopped seeing this aggregated delay in shipments for my entire fleet. So you see, that is the type of practical applications we deal with on a daily basis. Of course, there is the flashy ones that show up in the newspapers. We are building a supercomputing center. The government is doing this massive build up of AI, and they have good reasons for that. But in the ground floor, most companies are looking still at, okay, I like the concept. I will love to have a car that takes me and I don't have to do anything. But until that happens, I need a car that actually just parks so I can offer that as a value added for $1,000 additional to my normal vehicle. And some people will pay for that. Until they pay for that, I'm not moving to the, and now we'll actually drive my kids to school. So that's really where we see the industry today. Cautious, finding the applications that make sense on a daily basis.
No, makes sense. I think speaking of supply chain, one of the things that we've learned from COVID is sort of transitioning from sort of this just-in-time, highly optimized supply chains to just in case, right? We want them to be more resilient, reliant, surprise standpoint, and so on. So that brings me this sort of bigger question about life has changed this year, and COVID was definitely a strategic surprise, both for individuals as well as at the national or macro level. What are sort of some of the lessons from COVID from an AI, data science deployment or use case perspective? Sort of a general question. Who wants to go first? Yeah, Lewis, and then Sonam, please.
So one of the things that we've seen with a lot of the large companies that we work with is that when they're trying to use AI to do, to predict, for example, product sales, and they're relying on, traditional machine learning on historical data, that historical data is always a little bit questionable when you're looking at the data from last season to try to predict this season. You're already making a leap. This year with COVID, you're making a huge leap because there is no historical data of a COVID world, and I think it starts to reveal, one of the, the kind of dirty secrets about, applying AI to real world business problems, which is that when you're using traditional machine learning, you're making this assumption that you can find data sets that accurately represent the problem you're trying to solve. And for some things, that are, slowly changing, that those data sets exist. But for things that involve people, things that involve culture, things that involve society, the framework changes so quickly that these historical data sets are a problem. And that's one of the things, you know, that, you know, from my perspective, in terms of what we do, we, you know, we're always telling these large companies, in addition to these big historical data sets, you have this other database, this human database. You have these people who are, you know, the people in your organization or groups of people who are your customers, and they have knowledge and wisdom and insights that are continuously being updated. They, you know, they can extrapolate to this new situation of COVID in a way that the historical data sets cannot. And I think it points to the fact that for things that involve humans, keeping humans in the loop, and there's lots of different ways of doing it with AI, but keeping humans in the loop is really the best way to get results, rather than just trying to rely entirely on historical data. And COVID is, you know, a great wake-up call where, you know, the historical data just is destroyed for so many things people are trying to forecast right now.
Yeah, no, absolutely agree. We've had multi-sigma moves in much of the data streams, right? Sonam, you probably know more about this. So go ahead.
So COVID for the financial data set was like a crazy event, like everybody knew. In March, all the standard deviations were broken and prices went anywhere. You know, we saw negative oil prices at some point of time, and that is where, you know, any model that has been built which is slightly overfit on the data won't know what to do. This is not a situation that it has ever anticipated, and that was a point of failure for many AI models. If you had like a model that is built for such situations, that is built for a risk event, so that is the time when we saw, you know, certain funds which are based on, you know, black swan events do really well. And so it was a very, very complex time. From business perspective for us, it was again very interesting because all the users suddenly moved, especially in a country like India, from, you know, a human-driven process to a digital process. And when they came to a digital process, they are looking at more interesting concepts, not just the traditional ones. So that has been interesting for us and across the financial industry, I think.
Yeah, no, makes sense. The quickening of digitization is something everybody talks about, and that immediately brings in the data science element, because there's so much data being collected and new data, to you folks' point. So feedback from the audience is we'd like to hear more, you know, are there PowerPoints available? I think all my panelists are very esteemed and are very sort of searchable, in the sense, if you sort of Google their names, affiliations, you should be able to find other info, but through the organizer will try to get you these specific PowerPoints as well, but there should be more information if you search by their name. And this might be a question for Kirel. You'd have to interpret it. It's a bit of an open-ended question. How are we perceiving the study of multiple dimensions or multi-dimensions using AI? Comes from Vedant. So Kirel, do you want to take that? How do you think about the multidimensionality aspect?
Well, it's a difficult question, I would say. Thank you. Yes, basically, I mean, if I want to go back to like visualization, you know, most of the time when we want to make any decision, we, you know, come back to visualizing stuff, because as you said earlier, like the biggest part of our brain is dedicated to vision, and we try to make insight of what we see. And we have a very hard time basically visualizing when there's too many data dimensions or data points. So what we do is we try to, you know, keep one dimension, project onto other, and, you know, change the dimensions. So we have tons of different plots, and it's very hard to have an overview of what's happening if you have more than 3 dimensions, right? The brain is very well limited. So we always try to do embeddings, especially with AI. You try to take, I don't know, 50 different dimensions and try to find an algorithm that makes that project those 50 dimensions into 2 or 3. For instance, you have this TSNE algorithm or UMAP or tons of others. And each time it's always a compromise. So you think, yeah, you know your data because, oh, I can see a clear pattern, but sometimes we forget that this is just a projection of the actual, you know, distribution, which is in 50 different dimensions. So we have to be very careful about these models, because they don't really necessarily capture, I mean, what we can perceive, or I would say in the other sense, we are, as humans are very limited, and we only perceive something that we have. We are our priors, our biases, and having an overview of everything at once is quite difficult. So we have to be careful when we train those models. I'm sure. I hope that I answered a bit the question. It was not easy.
No, it makes sense. And I think humans, because we live in a three-dimensional world, we have trouble visualizing 4, 5, dimensions and so on. So dimensionality reduction, there's a lot of theory and techniques around it. People should sort of Google that. And I think this may be something that Santiago may want to start out with. The question is about how about a model that you don't have to train? So obviously on the edge, you want to have something that reacts quickly. So there are some techniques for zero-shot learning, but I think this person's primarily talking about negative oil prices in one case. Cannot be predicted, but we could trade them just smoothly. Well, you could trade them if the brokers and so on. This is more like the Y2K issue, right? So some folks had issues because they weren't ready for negative prices. So that was the real issue, that it wasn't an AI or data science issue. It was more a data conduction or data sanity checking issue. It said, oh, negative prices, I don't know what to do with it. But I think this concept of quickly reacting and behaving without much training, zero-shot learning, whatever you're doing on the edge might be interesting. Santiago, do you want to go first?
This is one of those times where I would like to have my chief architect here, as I am on the hardware side. He knows everything about this. We have been working with several companies doing that today. Okay, actually, one in particular, we are building a demo as we speak. So these are new techniques that you can have either, I would call it on-the-fly learning or live learning. Something that you are looking, as an example, you have a camera in a building and someone walks in and it just learns the person. And if it walks around the building, it's able to find the person again. As you know, there is a high complexity on following people in a crowd. So you identify the people, and what they are doing today is pairing a bunch of cameras together and trying to track the person through the cameras, right? So the new techniques, and that's one of the demos we are working on, take a person as it enters the building, trains itself live, and then it shows up in a different camera in the third floor, and it's able to say, oh, I know this person, right? So still we are seeing some training, but this is more of a ad hoc live training rather than is pre-trained for something else. So we have been talking to a number of companies doing this or variation of this. I would say most of them are in the late research state or starting to look into products. The particular one we are working with a demo, they have something that they can show. So I think that's coming very soon. It's a need, and most of our customers actually ask for that, because the main challenge, as everybody knows, when you go and get an AI system is training. And if you see the large amount of people today in many countries clicking, this is a tree, this is a car, this is a pole, and they are doing that manually to build these training sets that they either sell or use for their own purpose. That's one of the main key expensive things to get. So they don't need training. Research is well alive and kicking today.
Thank you, Santiago. We have a question for Louis from NIMIT, and then there's a question about emotions and sentiment, which I think Kirill and Sonam should be able to cover. But first to Louis, have you done any studies work using SWAM AI for a complex mechanical electrical system, such as operations of a power plant, and trying to optimize the operations?
Yes, that's a great question. And we haven't done something specifically mechanical like that, but we've done a lot of analogous things ultimately, when we work to solve a problem, the first step is people. So you can have a group of people who are experts in, for example, in that case would be experts in that mechanical system. Maybe they're the operators, maybe they're the engineers, and now we can bring them together as a swarm and have them surface optimal solutions to a problem. A similar scenario we actually did a study with the U.S. Army, where they were looking at cybersecurity. And in the world of cybersecurity, they have these small teams that are looking at all the signals coming in, trying to assess threats. And so it's an electrical system, lots of threats coming in from all around the world. And then this team has to then decide, which threat is the most important? How should they prioritize the threats? And so when we did a study where they did it manually, where this group of people would see these threats and then try to just discuss, which is the way they do it now, to say which threat is the most important. Or in this experimental case, they were working together as a swarm intelligence to prioritize the threats. And what we found was that they were significantly more accurate when they worked together as a swarm, and they were significantly faster. They were they were faster in their ability to converge on that solution. So again, from the perspective of swarm intelligence, if you have a group of people who are knowledgeable about a system, a mechanical system, electrical system, financial system, you can harness their insight in an optimal way and generate really really good insights for optimizing your system.
Yeah, thank you. Real quickly, Sonam, you may want to address maybe the sentiment aspect. You probably have looked at some sentiment from news and blogs, and then Kirill, I think the question is more around virtual reality and emotions and so on. Why don't we do those, and then we'll go to the closing comments by each one after that. But Sonam, go ahead.
Yeah, so I'm not an expert at sentiment analysis, but there are now so many firms in the financial market who are, coming up with these data sets based on sentiments. They are looking at social media data sets, Twitter sentiments. They are categorizing the people who are posting into various influencer groups. They're analyzing analysts. They're analyzing company data set, and they also they take out the company commentary that comes out, any news that comes out, and they extract information, which is something that we might miss, that okay, there's a management change, or there is something that will really affect the stock price in the future. So it is a very fascinating thing that is going on in the financial market, and that data is really valuable. And I mean, it also involves like getting a lot of history for you to train the model, because financial data set is different from any other sentiment analysis training data set. So it is a bit of an effort to collect the news, mine social media, and those data sets before you do the sentiment analysis. But obviously, it's a very fascinating thing. And if you look at the results of such models, they perform really well compared to any simple additional model. They perform really well around events, when there is an analyst revision, when there is a company earning, and around that, the type of sentiment that is going on, and did the company underperform or outperform based on that sentiment, is something that is a very good signal for people to pay attention.
Yeah, no, thank you. I think there are companies like RavenPack. There's a smaller company called Stock Snips here, which tries to extract snippets from news and try to do a thumbs up, thumbs down. Kirill, thoughts on sort of this virtual reality and emotions and so on, how that sort of feeds into your work?
Yes, so I've been exploring some of virtual reality stuff. So it's really interesting. I think the technology is not very mature yet. So like most people don't have any access to any virtual reality headset. It's you get dizzy. The resolution is really bad for now, but I mean, this is something that we should invest on now to have like really powerful displays in the future. What cool thing that you can do with virtual reality is, of course, having the spatial feedback, right? Feeling that you are completely immersed. And so what you can basically have the feeling of walking into your data. This is the cool thing that we explored. We did one project like this, the Montreux Jazz thing that I showed is not really virtual reality, but because it's still a full dome, it's quite immersive. So we tried other experiment where instead of having a headset, you were actually projecting, all around you. So it was very big, more than 10 meters wide as a diameter, all around you. It's a very expensive installation. The only problem that we had is that there's like to render, to have like good graphics on this kind of, number of pixels was huge. It was, I don't know how many, I don't know, 100 million. It was insane. So like the hardware was not sufficient. So on one hand, we know that you have more emotions when it's more, immersive, but at the same time, the display is a bit, it's not there yet for when you put it in front of your eyes. And if you want to have something, a very wide space, something that they use, for instance, to shoot The Mandalorian, the Star Wars, the new series, they have a very, big round display where they project stuff. You need like $1 million of hardware. So we are getting there. But I think now all the things that we undertook are a bit, I think they're less good than what they should be in the next few years. But it's a very interesting field to explore.
Yeah, no, it sounds like an exciting area, but I think we're coming up on the end of the session here. So we only have a couple of minutes left. So 30 seconds each, some advice to the professionals in the audience. Maybe start your sentence with a do or a don't. Santiago, you first, then Luis.
We have been using tools since the beginning of time. Nobody anymore objects to using a hammer to hit a nail. Now we are moving into the AI tools. 20 years from now, nobody will object to everything we are trying to do with AI today. Think about that as you ponder on the question how all these new technologies help us and why we should adopt it. We need to adopt them. And there was a question from the audience on healthcare. We already have, in my company, COVID detection for 7 months already in India for hospitals. And we have AI on DNA sequencing for the past 7 years. Think about that. Things that you don't know yet, but they have been already there helping your life.
Luis, go ahead, and then Kirel, and then Sonam will close us out.
Sure. So the biggest piece of advice I would give to folks in data science who are focused on especially forecasting anything that involves people is to just remember that people are smart and don't reduce a population of people to a few data points. It is it's convenient to reduce people to data points, but I see data scientists very often seem to think that these very simple data points are actually representing the people that they're trying to make forecasts about. And my approach, the thing that I've seen really work well is instead of treating people as data points, start to treat people as data processors. Try to see how can you actually harness the intelligence of the groups of people that are relevant, and it could be the people in your organization, or it could be your customers, or it could be your supply chain, or it could be your patients. But whatever it is, if you start looking at looking at people differently, you can start making much better forecasts than assuming that these simple data sets you have actually represent the people you're trying to make predictions about.
Thank you. Some final words of wisdom from Franz, Kirel?
Yeah, final word, I'm not sure, but I would say don't be afraid to, get technical, and push yourself into creative endeavors, especially with AI, to go deep into the system, try to really understand how they work and how you can modify them to make them create something unexpected. Go about the technicality to create interactive graphics with data, for instance, something that is not very common, right? To be able to explore something on your own and to better grasp the technology behind it so that you can use it in your day-to-day job, something like this.
Thank you, Kirel. And Sonam?
So my advice would be that adapt AI into your normal life, because like Santiago said, like very soon this will be a routine. This is like AI will be something that everyone would be using, and AI models, like we look at it, are not are seen as black boxes now. But if you go deep into it, they're not black boxes at all. They'll become simpler to understand as we move on in the future. So they are good tools for you to have, and I think the more focus should be on building a more robust and a very strong model that does well across time, um, than not adapting to these systems. So that would be my advice.
No, thank you. I think we couldn't get to all the questions, but I think all you folks have written, given other talks and so on. I think AI and data science is really about scaling expertise. I think Lewis made the point that humans are smart. They can be made smarter with data by interacting with other machines and humans. So I think we live in an exciting time. I want to thank all my panelists. I also want to thank Anand Dinani, who is the main organizer for the unconference part, and Jeff on the tech lead for this session. Thank you as well. So thanks again to the panelists and the audience for attending.